Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 8 minus 121 equals to 0, and we will solve this problem for the values of n. So in this problem we will find all the roots or all the 8 roots of this equation. So the very first thing we are going to do is, here first we rewrite this equation as, here we have n to the power of 8, and we will write it as n to the power of 4 and its whole squared, minus we write this 121 as 11 and its whole square, and it is equals to 0. So in the next step we will just use here the nice square identity, and you know about this identity. If we have a squared minus b squared, it is equals to a minus b times of a plus b. So here you see that we have n to the power of 4 be the value of a and 11 be the value of b. So now we put the values of a and b in this nice equation, so that now we can use this formula on the above term, and we will get its output in this form. Here we have n to the power of 4 minus 11 times of n to the power of 4 plus 11, and this whole equation equals to 0. So after this step we will again simplify this equation. So first I can simplify the first factor here, so that we can again write this n to the power of 4 as n squared and its whole squared, minus we will write this 11 as 11 square root and its whole square, and we write this factor as it is. So you have n to the power of 4 plus 11, and this whole equals to 0. So in the next step we will again use here this nice formula, and according to this formula you will get the outputs of this expression will be n squared minus square root of 11 into n squared plus square root of 11, and we have this term as it is n to the power of 4 plus 11 equals to 0. So after this step you will see here we have three cases here. So now I can break the next steps into the three cases. So our first case is, we write n squared minus square root of 11 equals to 0. So this is the our first case, and I can name this as equation number 1. And our second case will be n squared plus square root of 11 equals to 0, and I can name this as equation number 2. And our third case is n to the power of 4 plus 11 equals to 0, and you have n to the power of 4 plus 11 equals to 0, and we name this as equation number 3. So now in order to find the 8th root of the given equation, we need to solve these three equations. So now first we will focus on equation number 1. So here I can write from equation number 1, and in equation number 1 you have n squared minus 11 equals to 0. So here we move this minus 11 minus square root 11 in the right hand side, and you will write it as n squared equals to square root of 11. And you know that the square root of 11 will be written as 11 and its whole power 1 over 2. So this is the exponential form, and this is the symbolic form or square root form. So now we will in order to find the value of n, we will again take the square root on both of the sides. So we will need to take this sign on both of the sides, and here you have 11 to the power of 1 over 2 and its whole power square root. So now you see that these 2 and square root are gone, and here you obtain n equals to, here we will again write this square root as the power of 1 over 2, and you write it as 11 to the power of 1 over 2 and its whole power 1 over 2, and you will just write here the plus minus sign because we will take the square root on both of the sides of this expression. So now we use here the nice exponential law, and according to this exponential law, we will, if you have exponent to the exponent, so these exponents are multiplied by each other, so you get the two values of n will be 11 and its whole power 1 over 2 times of 1 over 2 equals to 1 over 4. So these are the first two roots of the given equation which we obtain from equation number 1. And in the next step we will move towards this equation number 2. So here you have the equation number 2 will be n squared plus square root of 11 equals to 0. So now we will just solve our equation number 2 here, and now I can write equation number 2. So from equation number 2 we have n squared equals to minus square root of 11. So here we need to take the square root again on both of the sides of this expression, so that you will get here the square root of n, and this is the square root of this term. So here you have these 2 and square root are gone, and it is equals to plus minus and now you see here you have the negative sign under the square root, and you know that it is equals to iota, so you will get here the square root of 11 and iota. So you know that the square root equals to 1 over 2, so if you have 2 times of square root, so it means that you have its exponent will be 1 over 4 times of iota. So these are the other two complex roots of the given equation. So now in order to find the other roots we need to solve equation number 3. So in equation number 3 you have n to the power 4 plus 11 equals to 0. So now I can first write here our equation number 3. So from 3 you have n to the power of 4 plus 11 equals to 0. So here we can solve this problem or this equation. So now we can move this plus 11 on the right hand side, and you will get its output in this form: n to the power of 4 equals to minus 11. And now we will take the square root on both of the sides of this expression. So you will get here n squared equals to plus minus of square root of 11, and you see here we have negative sign under the square root, so it is equals to iota. So here we have again two cases. So our first case is we write the positive term, which is n squared equals to square root of 11 iota, and the second case is we write the negative term, which is n squared equals to minus 11 square root into iota. So now in order to remove this square sign, so here we again take the square root on both of the sides in this form. So you will get here these 2 and square root are cancelled by each other, and you get here n equals to plus minus the square root. Here you just write this expression as 11 and its whole power 1 over 4, and you write iota and its whole power 1 over 2. So these are the two roots we will get, and now in this equation you will cancel these 2 and square root, and you will get here n equals to, and this is the iota sign, and you will write this expression as 11 and its whole power 1 over 4, and you will here you have iota and its whole power 1 over 2, and this is the minus 1 square root, so you gain 1 iota here. So when you simplify this expression you will get here plus minus 11 and its whole power 1 over 4 into iota to the power of, we will add these two exponents, and you will get here iota and its whole power 1 over 3. So these are the other two roots of the given equation. So in this expression we find the four complex roots. So these are two complex roots, these are two complex, and these are two, so these are six, and here we have the two roots are the real roots. So our real roots are n equals to plus minus 11 and its whole power 1 over 4. So these are the total 8 roots of the given equation, and this is our final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.